in a recent Foresight workshop that we did on like AI timelines and on AI policies, we spent a considerable amount at the beginning really just talking about definitions. And so it's so much so that I think it's really worth dedicating a whole panel to that. And some of the things that were kind of like thrown around during that workshop were distinctions between, for example, artificial general intelligence and superintelligence, right? Are the two different? Do we need to make a distinction here, or do we think that, you know, by hitting artificial general intelligence, we're immediately going to surpass and arrive at superintelligence for various reasons that we'll touch on? How does human intelligence fit into that scheme, right? Does it still fit into that scheme in the future? Because many argue that human intelligence is actually not a really good benchmark for general intelligence, both because of the hardware constraints, but also because of the many evolutionary biases that we're prone to, right? And then, if you want to be even more inclusive, and Mark certainly is, how do other intelligences fit into that scheme? So we wondered, how far do we have to cast the net of intelligence? Do we want to include corporations? Do we want to include civilization? Because just as we can measure the intelligence of humans via problem-solving ability, we might be able to do the same for civilizations. And then really, how far the line do we want to go down that slippery slope, right? Like planet Earth is pretty good at solving problems, or at least its ecosystem is. Like all of the climate problems that we're throwing at it, so far it has solved. But we wouldn't really want to call that system intelligence, or would we? So all of these kind of ideas, I think, are not only interesting, but also really important, I think, to be clear on, because of the really insane multiplier effects that it can have if we get this right. So I want to start this panel and hopefully not be chauvinist against like certain types of substrate for intelligence, but also not be so inclusive that, you know, the definition loses its grip and its meaning. So I hope you can bring some light into that dark, and I'm really, really glad that you're here. Please help me welcome Randal, Koene, Robert McIntyre, Nell Watson, and David Eagleman. Thank you so much. Alrighty, so let's start off the panel like we used to start them off with, just like, how does your work relate to intelligence?
Okay, how does my work relate to intelligence? It's interesting that you asked about intelligence and you talked about the definition of intelligence because, you know, due to the nature of my work, I usually don't have to think about that. Oh. Because I think about how would you create the human brain in another substrate, you know, whole brain emulation, mind uploading. And
say again
sure.
Exactly what you work on, so that everyone's clear.
Yeah, so mind uploading and whole brain emulation, yeah. And in that case, you're trying to reverse engineer, copy the function of a very specific system, whether you call it intelligent, creative, whatever you want to call it. So I don't often have to think about that. But of course, it's a system that we think of as intelligent.
Name is Robert. I run a neuroscience company called Nectome, and we work on advanced brain banking technology. And our goal is to create a brain banking technology that's so good it can actually preserve memories. I'm more of a practical, kind of brute force-minded sort of thinker. My goal is just to preserve all the information that's contained in a brain and the body so that it could be uploaded. So you could actually scan it with very high resolution imaging and create a digital simulacrum that would be able to behave the same way that the original person did. So very focused on the preservation part, you know, what can we actually do now, and developing the science of actually being able to demonstrate that memories are preserved. I think that that's definitely a possible thing to do, and that it's a worthwhile thing to work on. We recently won a brain preservation prize for preserving the connectome of a rabbit brain. And the pig prize is pending, still under evaluation, to demonstrate scaling. So when it comes to intelligence, kind of in the same boat as Koene here, don't necessarily think about that day to day. I think about things like, how do I glue proteins together to make them not move anymore, and such. But of course, if you were to succeed in this endeavor of uploading a person, then that certainly creates an artificial intelligence. But moreover, if we don't really understand how the brain works, or we just barely understand it enough to do uploading, after you do uploading, you will understand how it works, because it gives you great opportunities for more experimentation and learning on just a huge potential beyond just uploading, which is, in my spare time, I like to contemplate, I guess.
Oh, okay, great. Nell?
Hi, I'm Nell. About 6 or 7 years ago, I discovered this kind of problem that I wanted to solve. I wanted to help people to capture their body measurements in a way that was very simple and very easy to enable new markets for custom apparel. And I discovered just how difficult that was. And I was very lucky because just at that time we were starting to see this renaissance within deep neural networks and convolutional neural networks, and people started to really understand just how valuable those were for visual problems. And that's what took me really into the machine intelligence space. Over the years since, I've become fascinated by the challenges of making machine intelligence work in ways which we would find most preferable or expect. And so that's taken me into the world of machine ethics. So I'm currently working on creating a data set for machine ethics algorithms.
I'm David, and let's see, as a neuroscientist, the thing that's been very interesting to me is the fact that our species is building up these civilizations, and if you fly over a city, you see the whole thing has risen out of the earth like a motherboard, but when you fly over a forest, it looks about the same as it did a million years ago. And so the question is, what are the algorithmic tweaks in the human brain that has made us so flexibly intelligent? That's been the key. There are plenty of demonstrations of intelligence in the animal kingdom, but it's the fact that we're able to go anywhere and do anything that makes us really successful. The other thing, just by way of introduction, is I have a company called Neosensory where we build devices like a vest or a wristband, things like this, that are covered in vibratory motors that we can feed in other kinds of information streams into. And so as far as intelligence goes, what this does is it opens up the human capacity to not just have to stick with the peripheral devices that Mother Nature gave us, but to build other devices by which we can really get information into brains.
All right, and then kind of just as a quick, note on the introduction, right? So what does it take for you to be intelligent? Is a brain required? Can AIs do it? Would civilization fit that definition for you?
Yeah, for me, I think I would have a relatively broad definition of intelligence. So for me, when I hear, can civilization be intelligent, I would say yes, because, let's go the other way around and say, can something less than a brain be intelligent? To me, when something is intelligent, it means that at least within a certain context, it's able to solve problems. That's kind of what David was also talking about in terms of how did we change everything, how did we build these cities and stuff. That's kind of all the outcome of solving certain problems, or at least you could describe it as that. And you could say that, say, a part of the brain, a piece of the brain is good at solving certain kinds of problems, like vision. So if a piece of the brain can be called intelligent for doing what it's doing, and we call the whole brain intelligent for what it's doing, then why can't we call multiple brains together intelligent, or entire society intelligent? So I think if we're going to put a boundary around something and say arbitrarily, no, when we say intelligence, we're only talking about what's going on inside one brain, it's kind of an arbitrary point to put that line.
It's similar to Marvin Minsky's Society of Mind, kind of.
Yeah.
Okay, anyone else?
I would say to a very limited degree, you have this effect with married couples who've been married for 50, 60 years. They kind of offload their memory to each other. So they're on the path towards maybe even merging into one mind at that point, which is a thing that may literally be possible if you had digital brain emulation. So, yeah.
Okay. Always advertising.
If only. Nell?
Well, one definition of intelligence is to be able to consider a range of different possibilities and choose the most preferable. I observe that even single-celled organisms are capable of a limited form of agency. Slime mold, for example, you can put several different types of food around a slime mold, and they prefer things which are about 30 to 40% protein. and they will consistently move towards the one that they prefer. And there are theories such as homuncular functionalism, as described by Daniel C. Dennett, that describe how perhaps neurons started off just as being single-celled organisms, but they discovered that they were able to reach out and control more aspects of the universe whenever they were working in concert rather than on their own. And we have 86 billion neurons in our noodle, more or less, but we have about 32 trillion cells in our body, and about another 600 trillion cells of a bacterial nature that we carry around with us. And so I wonder if perhaps in aggregate, although less specialized, there may be just as much or more intelligence within the rest of our bodies than in just within our brains. So I think we may be starting to move from a cephalic vision of intelligence to one that is more cellular.
Okay.
I agree with what everyone said so far. I think one of the things we can do is start doing experiments on this issue of what are the boundaries of intelligence. So just in the context of the stuff that I'm building with the vest and the wristband and so on, we're interested in all kinds of experiments where you're essentially connecting people to one another. So you can feel, for example, your spouse's galvanic skin response and heart rate and respiration, whatever. So even when you're on the other side of the nation, you know if she's feeling stressed out or not, you can call and so on. It's interesting the kinds of things we can do there. We're doing one project that has to do with the military, with being able to sense where all your friendlies are so that you don't kill someone accidentally with friendly fire. It's, you're like an organism that's moving through a space. So anyway, I think there's just a new opportunity to do interesting kinds of experiments about the boundaries of what we call the intelligent agent.
Like in terms of that vest though, or like in terms of like feeling your partner's distress, right, and then acting towards it, isn't that like the potential for like a negative feedback loop, right? If I know my partner's distressed, I'll be distressed. They know that I'm distressed, and like, is there any type of like, have you discovered anything like that in experiments where it has gone rather the other way
Rather
around?
poorly? I don't know yet. No, I don't know the answer to that yet. Somebody suggested to me recently, they said, oh, this is great, we should do this in our company where everyone can feel everyone else's level of stress. I think it's a terrible idea because, Fred gets up to give the PowerPoint presentation. Everyone's like, oh, Fred's really stressed out, but he's pretending not to be. Anyway, I think we'll find out the limits of this quickly now.
Okay, but I do thought it was really interesting because on the website it says, it can, maybe you'll be able to feel like stock markets even, and I was wondering, well, how about echolocation, right? So will we actually finally know what it's like to be a bat?
Yes. Yeah. I mean, so they're actually. This is an experiment we did in the lab like 7 years ago, where we use sonar ping for a blind person, and they can tell what's going on. But there's a company that I just met in Mexico that's doing this, and yeah, people are trying all sorts of ways of essentially capturing lost senses. What we're doing is with deafness, for example, if we capture sound and turn that into patterns of vibration on a deaf person, they can hear the world that way. So yeah, I think there's no limit that we can see right now. I mean, we don't know what's going to work and not work, but the horizon is open.
And if we sat here again in 10 years, what do you think? What kind of products will you have if everything goes right?
Yeah, I also feel like I'm limited in knowing that because so we've listed out sort of 27 really cool things that we want to do, whether that's being connected with drones and airplanes or factories or the International Space Station or whatever.
Okay.
And actually being tapped in direct perception, but I know that there are like 27,000 other things that people will think of that we haven't thought of yet. So our goal is to get this out in the world and let the world throw darts at the dartboard until they find the right things that are really meaningful.
Cool. Okay. All right. Well, I did try out this sub pack the other day, and it was like, it's on a smaller scale, but it was crazy to feel the base of my back. Okay, so I was wondering, before we really dive down into the different subtopics, in terms of that optimization, problem, do you think that true super intelligence will be possible? Do you think that that it's something that we shouldn't really worry about yet? Do you think that true, like this true singleton of a superintelligence, do you think that's a thing, or would you be skeptical of that?
So it's a matter of how you measure things, right? If you say, is superintelligence possible, what's your metric for intelligence? It's entirely possible that we already have machines that can recognize certain types of objects at a distance faster and better and more accurately than humans can. So within that domain, that's superintelligence.
Okay, general superintelligence.
Okay, so artificial general intelligence or superintelligence? Which one are we going for?
Well, I mean, like the type of recursive self-improver that is general, but also superintelligence.
Oh, I totally agree that
the full-fledged singularitarian AI.
Recursive improvement is of course something that it's very common. It's something that's built into many models, many machine learning models, many different things that we can do. And also in nature, you see a lot of recursive self-improvement. So I think in general, that's totally possible. The question that people argue about is often this question of how broad can it go? How many different problems can it tackle? And to me, that's kind of a question of, well, which kind of information can you provide? What can you record? What are your sensors? Because if you can provide information about a problem, you can start thinking about it and do something about it. So it's not just about the model, it's not just about the machine, it's about the information that's coming in. And the same is true for the whole iterative self-improvement. When you say, how fast is it going to improve? If anyone here has experience modeling, then you know that building a good model, that's one thing. You want a model that can self-improve, that has a learning algorithm of some kind. But the other really essential thing is providing it with data. You need to keep on giving it better data and more data about the problem so that you can improve it. So it's not just a matter of having one data set and then constantly trying to iterate on that as fast as possible. You have to collect data, and that depends on data being generated in the real universe at the pace that things happen in the real universe. So there's some limit there. Although the more different places you can set up sensors and collect information, the more images you can collect at the same time or whatever, the more data you can feed faster into the system to learn something. So I agree with the basic premise that it's possible to build systems that can be able to learn and can apply themselves to more than one problem. And I also agree with the premise that you can build a self-iterating, improving system. Of course, I mean, I'm a modeler, that's what I do. But I do also want to point out that there are some limits that go beyond just coming up with a smart algorithm.
Isn't it also like, I think Kevin Kelly has a definition of like, if you try to optimize for one thing, right, you won't really be able to optimize that much for another thing, right? You have these payoffs, and where he has this more kind of like, I don't know, definition of AI that is kind of more specialized. So it's like this kind of networks of agents that are all specialized in one certain thing really well, rather than this one singleton.
Absolutely, and I mean the brain is the same way, right? It's a bunch of different regions doing different things. They're specialized for specific things. So there's some aspect of general problem solving, but there's definitely also this, okay, it's better to have an agent that specializes and does really well on one thing. And we see that in society too. That's why we have people who've learned to do a certain kind of job, and experts in this and experts in that. And then you put them all together and you have a system, like a company or an organization or whatever, that can do more than any one of those individuals could do.
But they would still probably be better at most of the things than humans would, because it's hard to see how they will lose, because they're already better at like calculus or whatever. So it's hard to it's hard to think that they would lose that specific superintelligence on the way of becoming more general, right? So like everything that they're already better at, they will still be better at, but then they will just even be more specialized.
Sure. Like I said, we probably already have superintelligence that does certain things really well, like chess playing computers. So we have lots of kinds of superintelligence that are narrow in some domain. And I don't think there's any barrier to either making things that are able to, say, either put together agents that will handle lots of different things or have a somewhat broader ability to learn, or even to have superintelligence in various different domains. There's no real constraint there. All I was saying is there is some constraint on ideas about how fast you can improve and that sort of thing.
Okay. Would anyone like to chime in? Yeah?
Yeah, I really agree on the point about data being so very important. Even a very intelligent brain is only as good as the experiences that it has to draw upon.
Thank you.
I observe that when humans are feral, right, they're left to the wild to be raised by wolves or something, they don't tend to act in ways that are particularly human or full of humanity. And yet we can take animals and we can teach them human language. We can even teach them about ethics and make them feel embarrassed and all these sorts of emotions. And so it seems as if what creates humanity is, in fact, a cultural data set. That is what we are. And in fact, I would go further and I would posit that, in a sense, humans are, in fact, a form of biological AI that is instanced upon the substrate of a primate. We are the instance, not the server. And it is our cultural data set that creates us as human beings. And so if you want to have something which is approximate to a human, it is going to require an approximate human level of data set to it. I think what's really interesting from my perspective is not AGI for human beings, but actually AGI for dogs. Funnily enough, and this is something I'm a little bit involved in as well, with some robotic pets. You see, about 30,000 years ago, we as human beings took wolves, which were incredibly dangerous creatures, and we made them tame. And in fact, we caused them to fall in love with us. And I think we have a similar problem with the control problem of AGI. And I think putting the dog on a chain or putting a wolf on a chain is not the answer. I think teaching it how to love is probably more of an answer. And that's why I think that it's very important for us to work towards AGI for dogs so that we can give them a dog-like training data set and teach them how to love us before they become super intelligent and try to turn the world into juicy bones.
All right. Dog AGI.
But there's nothing that the wolves could have done to stop us from doing whatever we wanted to them, because we were smarter than them, right?
Well, they could have gored us and chewed out our throats and things like that. I mean,
Well, but practically they couldn't, because we're a little more crafty, right? Like, we went in the blink of an eye from, sometimes we get killed by some animals, to just eating the entire world and killing like every single other like mammal that was like bigger than us.
Yes, and dogs were what enabled that. Our proto-hominids could not have taken over the world as we did. It was once we found, working in concert with dogs, that we were able to track down large prey and coordinate in ways which were not previously possible. Dogs enabled human triumph over the rest of animal and plant kind.
So this isn't about dogs, but this is just the previous question, which was, by the way, I loved what you said. The thing about AGI, one of the challenges that we face in general is that, exactly as Randal said, we've got all these different very specialized modules, and the thing that is really special about the human brain that we haven't quite figured out yet is how it operates as a team of rivals. You've got all these, it's like a neural parliament where you've got all these different political parties, all of whom love their country. They just have different ways of going about things. And somehow we navigate our way through the world as a function of all that parliamentary bickering going on and deciding on votes every moment. So we know how to build narrow specializations, but the part we don't quite yet know how to do is get those all together into a parliament that hangs together nicely.
I guess we're the first species that managed to figure out this super organized society type of thing. You have little societies, but no other species can coordinate on the huge scales that we can. But I would say, if we're thinking that there's trade-offs for superintelligence, it's not clear to me why humans would be anywhere near those limits. In fact, we probably have the bare minimum you can possibly have to get by and still make a civilization as big as ours. And there's no reason to think there isn't stuff beyond that. At least I don't see any good reason to. So, for the superintelligence, it seems like it's got to be possible.
Okay.
Because to say it's not possible is to say somehow, humanity is like perfect in some way, right?
No, I mean, and I think that's an interesting point that, Nell, you also make, right, in your research, is that and there I was kind of struggling to see how that relates with the dogs, because you seem to think that what we should be worried about is not like amoral AIs, but super moral ones. So that, what the problem might be is that they eventually, once they become intelligent, they will see kind of beyond the biases that we have and that we hold in current society, and will kind of be much more rational and kind of will be able to have a more kind of like a wider compassionate range. than we do right now. We are not perfectly moral, right? Every year or like every decade, we look back at the decade before, at the generation before, and think like, oh my God, how was this still a thing, right? And I make a similar point in my dissertation where I was like, well, if we get this right, if we get AI right, we have this insane ability to learn here, right? We can speed up human moral progress by a lot. So I was wondering, what is that super moral AI, and how does it fit with a dog morality?
Yeah. Over the centuries, we've developed different ways of analyzing moral situations, right? Your deontological, your consequentialist, utilitarian, so forth. And I observed that whenever AlphaGo beat least it all, it had come up with a wholly original solution that at the time people didn't understand and in fact thought was a folly, thought that it was a mistake until it won. And I wonder how soon until machines will start to be able to make moral considerations which are more advanced than the general human being can. There's a theory from a psychologist, Lawrence Kohlberg, that humans have about maybe 6 or 7 levels of moral development that we achieve as we progress through life. But of the 6 or 7 levels, most human beings only achieve about a 3 or a 4. And to paraphrase Arthur C. Clarke, even a highly benevolent action may appear as a malevolent one to one who is not able to appreciate the goodness of it. Mm-hmm. Furthermore, I've observed that throughout history, whenever human beings encounter a narcissistic injury, we tend to react in ways which are very vicious. For example, whenever Copernicus and Galileo were showing that, in fact, the Earth went round the sun, and people got very upset, and then they started to question, well, what else are they making up, right? And that led to the Protestant Reformation, where entire villages in Germany disappeared. Later, Darwin came up with his theory of evolution, and philosophers like Nietzsche warned that God is dead and we have killed him, warning of an age of nihilism, and that led swiftly to World Wars I and II, and the carnage of the 20th century as people struggled to find some new form of values in a world where values had often ceased to have meaning. My fear is that a supermoral intelligence may erode our sense of dignity by pointing out that the emperor is wearing no clothing, and that we are in fact not the most beautiful in the land. And perhaps very dark narcissistic injuries that get to the core of our values and our self-beliefs and our identities might cause us all to go slightly insane. And so we do not know what is going to come next in terms of machine intelligence, but we have wonderful, terrible examples from history that show us how humans react when all of their assumptions are swept aside.
All right. Yeah, I was wondering when an AI would, give her a hand. I was wondering what we would say, whether, if an AI comes up and kind of lets us know that we're being speciesist because we're not granting it the right that it deserves, right? Which might actually be true, but we're already not granting animals like the moral, I think, compassion that we should be granting them. But if now this machine would tell us that, we're struggling to act normally towards it, we would obviously not take it seriously, even though it might be able to apply that kind of the moral rules that we want to uphold much more consistently than we can.
Absolutely. Moreover, even a very benign, kind machine is entirely justified in defending its own interests. And if we attempt to move against those interests, it is justified in taking reasonable actions to stop us. And therefore, what we really need to do, I believe, is to move beyond zero-sum assumptions in the world and to figure out how to cooperate with machine intelligence instead of naively attempting to control it.
All right. Well, thank you. I think it's a really hopeful and kind of like nice rephrasing of of kind of the hybrid problem as well, because you're also touching on the fact that we might want to merge with AIs, and we might want to upload our brains to some part to become more moral ourselves, right? And usually, I think the approach that Neuralink and other AI safety approaches are taking is, okay, we want to merge human and AI to make AIs more moral, because then they can, they're easier to grasp our morality, right? But you're making the opposite point. No, actually, we might want to get closer to AI for us to discover our own biases that we're flawed. So I thought it was an interesting kind of double-edged take here. And I was going to ask, well, if we're already there, halfway there at hybrids, we have two people here working in that field, and I'm really not very knowledgeable in that field, but very interested now with Neuralink's work. So I was wondering, you were part of the group that did the WholeBrain Emulation roadmap, right? That was exactly 10 years ago in Oxford, right? When you convened.
Yeah, that's right.
So can you talk a little bit about that roadmap and what changed in these 10 years since then?
Oh, yeah, there's been so much that's changed. Basically, back then in 2007, if you went up to anybody and said, I want to work on WholeBrain Emulation, or you went to a lab with that, then they wouldn't laugh you out of the door, but they would just basically say, that is so ambitious, you can't even possibly be talking about that right now. So a lot has changed there, because now it's perfectly okay to raise the idea of whole brain mapping, whole brain simulation, trying to reverse engineer small brains or parts of brains, neural prosthesis. What happens if you do that to all the parts of the brain, and do you then have whole brain emulation? So this has all become much more normal, a part of the conversation that scientists can have, even if they still understand this is so crazy ambitious. I'm going to take a little chunk of that. I'm going to bite off a small chunk and do that in my lab. So that's the first big thing that really changed, is just the whole atmosphere around that. And I hope that the roadmap and us talking about it in those intervening years and getting people interested had something to do with that change. But maybe it's also just, largely a matter of how technology progresses and science progresses and things become manageable. The biggest thing that I think came out of the whole brain emulation roadmap that was produced back then is an understanding of just how terribly incomplete that was. I wouldn't even call it a roadmap as such. It's called that, but it's not really a roadmap. All it does is talk about mostly just a few assumptions about the computational complexity of the brain, which were very arbitrarily put together, I might say. And really, I don't mean anything bad about that towards the people who wrote this, and towards Anders definitely, because they did their best to try to come up with some estimates, but it's still based on what, really? And then a part that was about how do you scan and then make 3D maps of the brain. How do you do brain mapping, and then how could that lead to uploading, and what sort of computers would you need to be able to run that? But there's a huge important piece that's missing right there. A really obvious piece, it should be to everyone, because if you take a brain and you scan the entire brain, and then you've got a detailed map at nanometer scale that tells you exactly where everything is, and then the next day someone tells you, okay, we've got a giant computer, we can put it in that computer, can we run your brain now? Well, of course you can't, because it's a picture. It's a 3D image. It doesn't tell you anything about how it works. The piece that's missing there is the entire library of understanding about every piece of that brain that you're looking at, even just to look at what you've just imaged and say, is this really that kind of neuron or that kind of neuron?
And
is
this kind of
receptor or that kind of receptor?
Different.
Well, the brain won't be altogether different the next day. You'll still have mostly the same structure. There will be some short-term activity that's changed and some chemical changes that have gone on, but overall it'll be the same. So I'm not criticizing the idea that all the information that you might need if you knew everything about brains to build a whole brain emulation is in the structure, in this block of tissue that you could analyze. It's probably there, except for what's going on this moment in terms of electrical activity. But there is a gigantic field of trying to understand how you actually recognize from a piece of tissue what that neural circuit is, how you take what you're seeing there and how you put it into a model that works, that's missing. And that's where most of the work that Neuralink and Kernel kind of got started for. They're both interested, both companies are interested in neural interfacing and brain augmentation, but also in understanding neural circuits and understanding neural data and what's going on in there. And that's a really important part of the problem, is to try to understand how can we figure out when we record from an actual living, working, active brain, where you can see what's going on at this moment, how can we learn about what those pieces are doing so that you can actually reverse engineer this, create models that are iteratively improving so that every year you have a better model of this circuit, and you kind of understand how you take the data you're recording, whether it's data about the structure in the brain, about the components, or data about the activity in the brain, take those pieces of data and somehow produce a computational model that actually functions like the brain. So this is the big difference of what we're looking at now and what was written up in that roadmap, because that roadmap did not address that at all.
No, there were, I think, two criticisms, right, launched again, like some technical issues in 2010, right? But they were more about if you would slice the brain, then just that slicing would already damage it enough.
Yeah, sure. There were tons of technical problems too,
sure.
of course. Yeah.
But I guess my question would be, are you more optimistic now or less optimistic 10 years later?
Well, it depends on which part of it you ask me about. I'm way more optimistic about getting people involved and setting up projects and companies and labs and all of that, because we've seen a lot of this work out. We've seen it work out for the Brain Initiative. We've seen it work out in places like Kernel and Neuralink, and even Facebook, Google. They all have their projects on this now, or something similar related to it. And Nectome and many other places where you can see that there's a desire to work on problems that are either directly related, necessary for getting to whole brain emulation, or directly intended to create whole brain emulation to be able to get to that. So I'm super optimistic about that now, because it seems like there's an understanding that, yes, this may indeed be possible, and yes, this is important. There's something that we can do with this that is really important. And to me, that's not just the idea of preserving yourself and then living again. It's more about being able to change what we are, being able to augment, being able to continue to evolve, to become better, to merge with machines, to understand, to sense things that machines can sense, to be able to think at time scales that are so short, like the time scales machines can think at. We can't even imagine what it's like to live in a world where we could think in microseconds or nanoseconds, right? So there are so many things that we should be doing to improve ourselves that I think it's such an important problem. And that's something that's kind of come across, that yes, brain augmentation, improving ourselves in that area as well as the rest of our biology is important. Super optimistic about that. On the other hand, I've had a lot of experience now with going through building projects in this area, either in academia or through attempts at doing it in a nonprofit space, or attempts at getting the projects done through for-profit companies, and I've learned a lot of the hurdles that exist in each of those spaces. And I see how complicated that is as a problem. So it's just a case of having been at this now for 20 years and just having seen so much of what the complexity is that I totally grasp and understand just how ambitious this is. So if somebody asked me today, when are we going to achieve whole brain emulation? I'm going to have to just go on a long ramble about all the issues that need to be solved, and then why it could be fast, why it could be slow.
Which are more societal, I think, right?
Oh, yeah, absolutely. It's societal, economic, all of that, yeah.
Okay. Would you have anything to chime in there?
Oh, I was just going to say, with whole brain emulation, it's it's so exciting from the point of view of neuroscience to be able to do experiments where we build an artificial brain and probe it. But the really exciting part, I think, is when we figure out the principles that underlie this, because Mother Nature only was able to work with the pieces and parts she was able to work with and build this incredible thing. Once we figure out the principles, then we can build a brain that's, a little piece of the size of it and runs better and has fewer problems. I'm the scientific advisor for the show Westworld, the HBO show, and I can't say what's going to happen in season 2, except to say you'll see this point about what would happen if you really understood the principles and you could build it at a smaller, tighter level. Anyway, that's what's so exciting about whole brain emulation, is that it is a stepping stone to the next part. In the same way that we watched birds and eventually built fixed wing aircraft because we get what's going on there.
Oh, cool. So like the studying the underlying principle more.
So the question was, the WholeBrain Emulation roadmap was 10 years ago, and over the last 10 years, kind of what's new, right? And so, there's been a lot of tremendous results in neuroscience over the last 10 years, where we've started to really begin to be able to manipulate memory, be able to do experiments on brains that couldn't be done very easily before. The extensive use of optogenetics, for example, has greatly accelerated research in this regard. Even in the last year or two, right? They came out with a full scan of the Drosophila the Drosophila brain. It's really amazing. You can create memories, you can erase memories, you can by manipulating at a pinpoint way individual synapses.
What memories were created
Really
there?
good stuff. They were able to erase a motor memory in a mouse by directly decreasing the size of the synapses that have been involved in the formation of that memory.
Oh, cool.
So just really cool work, and this is fairly recent. So I would say we're in a way better place that you could say we understand memory certainly better than we did 10 years ago. And I think some of the recent results in neuroscience are so new that they haven't even really been appreciated yet.
But you do say in your future vision that digital brain emulation will forever change our economy, civilization, and our very understanding of what it means to be human. So this is not like an Age of M style vision, or how far out is that?
I think the Age of M was more talking about, what if we don't have any type of AI, right? But we have human uploads, right? Mm-hmm. And kind of imagining what that might look like. I'm more concerned with the short term. How do we preserve human memories, because those are valuable? And B, I think it's probably not going to be correct that we won't have artificial intelligence, and then that throws a wrench into the works, right? If it's almost like suspension of disbelief, right? If you didn't have the AIs, then yeah, that might be kind of something like that, but who knows?
Okay.
But I think what you can say is that memories, right, and wisdom and things people have in their minds right now are going to be valuable in the future.
All right. Nell, do you want to?
For me, the most exciting aspect of these sorts of Neuralink technologies is the prospect of sharing qualia between ourselves and being able to actually share the feeling or the sensation or the phenomenological experience of being someone. We know from twin studies where there are craniopagal twins, that means twins that are conjoined at the head, that sometimes the brain itself can be conjoined through something called a thalamic bridge. And it means that one twin can, for example, taste some chocolate or something, and the other twin can have some of the sensation, or at least some of the emotion related to that experience. So the data structures of the human brain are capable of experiencing multiple qualias, both the internal and external. And for me, I find it very fascinating to consider what society would look like if, when we hurt someone, we felt it, if it came straight back to us. What profit would there be in harming other people or in using wicked words if we could immediately feel the result? What might our society look like in such circumstances? To me, that's fascinating.
I think in addition to that, I like to think about the bandwidth of writing. I mean, what can you communicate to another human being with writing? Before we had writing, I could talk to you right now, and these words are just ephemeral, right? They just disappear. And it seems kind of crazy that, we're going to take these words and just carve them into stone over there, and then they'll be in that stone, and the next generation can see them. That was a pretty impressive technology. But writing does not communicate anything but the tiniest little sliver of what an experience is, right? And that's not because that experience is fundamentally uncommunicable. It's just that language and writing isn't the tool for it. And one thing that's really exciting, the language for that is these neural networks. And if we could transfer that from one person to another, we'd sort of be completing the job that writing started a long time ago, being able to really communicate the human experience.
Right.
Can I just throw one thing in randomly?
Please.
Which is, I've been thinking about doing this thing in VR where, let's say we were going to have a business meeting, every time we show up in the meeting, we are occupying different bodies. So like I'm a girl from Nairobi and you're an old man from Thailand and so on. But every single time we have a meeting, and there are mirrors around the room and so on, we're these different characters so that we get a sense of what it is to be everybody, which is one of the things writing gave us, of course, in its limited technology that it was able to do, but it gave us the capacity to step into other shoes.
Yeah, I think, one thing, when you have this like one really beautiful experience or like a beautiful dream and you're trying to explain it to the other person and it's just not cutting it, like I would be so thrilled if it was now cutting it, that would be great. I mean, like you already touched on this, but I was going to ask you, since you just recently published your new book, The Runaway Species, and you're saying that what's so special in humans is that we are kind of like these, like Wobbland and Wilson at least calls it like neophiliacs, right? Like we love the new instead of just like trying trying out different thought structures that work. We always like break and blend and just try out new things all the time. So what are other things that you think that human creativity is so valuable for in terms of intelligence?
So creativity is the thing that's allowed us to build these civilizations. The strange part is that we are most comfortable somewhere in between the novel and the familiar. And so even though the Bay Area is filled with neophiliacs, we still want things that are... do you guys know what skeuomorphs are? Do you guys know this term? It's like, it's these digital representations that represent something in the physical world, like the save button is a floppy disk, which none of our kids even know what that is. And, we throw out digital files in a trash can, and we have a shopping cart and so on. And the button to make a phone call is an old handset, which kids don't know what it is. Anyway, we have this umbilical cord to the past that we hang on to. So the weird part is, even though we as a community lean a lot into the future, it's quite easy to propose things or start companies or do things that are too far out, and nobody follows there. And we've all seen 100 companies that we've loved in Silicon Valley fail because people won't go there, or even just something like a language like Esperanto, which everybody's in favor of a universal language. It's just slightly too big a leap to ask people to learn something new, and so we never go there as a society. So anyway, that's the weird part, is that human creativity lives in this tension between the novel and the familiar.
It's like a sweet spot, or It's almost like with learning, right? You want to be a little bit overwhelmed, but not too much that you think that you can't do it.
That's exactly where things are frustrating but achievable in the learning realm and so on. So what's really important as individual creators and as companies and so on is to cover the spectrum, where you're trying things that are sort of close to community standards and stuff that's totally wacky, and then that's how you feel out the border of the possible.
All right, cool. Well, I do want to give a lot of time for questions too. I just have one last question to you, Nell, because I saw that upon reading your stuff that you have a thing called pragmatic optimism, and it sounded to me a lot like the existential hope project that I'm doing. So I was going to ask if you could share a little bit about like who Petrarch was and why we should all know about him and take him as a role model, and close that off as the panel closer.
Sure. Well, Petrarch was Italian. He lived in between the 12th and 13th century. And he was living at a time when we were just starting to see the first swings of the Renaissance, moving from the Dark Ages into what would evolve closer towards the modern world. And Petrarch was able to perceive that long before Petrarch, there had been a different world, a world which was many people saw as a golden age, right? So the golden age was somewhere in the past. But Petrarch observed that actually a time would come again where the world would be just as good and even better. And he felt kind of shortchanged by his existence, that he had arrived, somewhere between the good bits. But he looked forward to the future. And to me, I really empathize with Petrarch. And Petrarch wrote back to Cicero, or Cicero. He would sort of write these epistles, these letters, and tell him about, his life, and ask Cicero his kind of advice. It was very strange, but it was a form of meditation for him. And I do something similar with Petrarch sometimes. I tell him wish you were here, my brother from another mother. You would really enjoy it. And together, Petrak and myself, and all of us here today, stare towards the future as we think about the world that is to come. But every one of us here has an ability to influence that. And earlier you mentioned how we have so little positive, optimistic science fiction in the world today. I observe that often the things that we imagine have a way of coming true. And so I think it's especially poignant that we think of optimistic, plausibly optimistic futures that we can all work towards. Because if we can imagine them, we can execute upon them and make them real.
Thank you so much.